Hello, welcome to another episode of our series on how to use GeoGebra. In the previous video, I have presented a particular view of the software that is the probability view. And under this view, there are actually two tabs that we can use there. The first one is the probability calculator, and the other one is our statistics. So statistics comprises of the different hypothesis tests and also the different estimation techniques that we have. Let me guide you on how to use these techniques. I'm going to show a sample problem where we can use these different hypothesis tests and estimation techniques. Let's go ahead and open our GeoGebra. Again, the probability view can be accessed by clicking probability in the right part of our window, or you can actually go here, click these three dots here or three squares, and we can also find this probability view. Let us first remove this one. Let's close it. Do we need the input bar? I don't think so. So let's close this one also, or we can just slide it here. In the last video, as I have mentioned a while back, we had these probability distributions in the last video. So if you are not yet there, if you haven't watched that yet, I would suggest that you watch that video before you proceed to this video, because in this presentation we're going to focus on the other tab, on the other functions of this view. It's called statistics. It's here, and under this view, or I mean this sub view, there are a lot of things that we can do. We can see the list of things here that we can do. We can conduct a hypothesis test. So a hypothesis test is a statistical process that we do before we infer about the population based on a sample. First hypothesis test here that we see is called z-test for a mean, and then we have t-test for a mean. And these two tests here are tests for one samples only. So we have a characteristic, the mean, from a sample, and then we test it over a constant or any number. We also have z-test for the difference of two means. This is the test that we use when we are comparing two samples or when we are comparing two populations, t-test. And then we also have a test for proportion and the difference of two proportions. We also have a tab here, or a function for estimation of means. We can use z estimation, we can use t estimation. We have an estimation technique for the difference of two means. We can also estimate the proportion. So anyway, I will not be showing all of this one. I will just be demonstrating some of the most common hypothesis tests that we have here, and also the most common estimation techniques. Although all of these are common, what I will do is to give you a problem, and then we identify which is appropriate, and then conduct the hypothesis test. So let us have the first problem I have prepared here. So let's have this one. So what is a z-test? One sample. So basically what we want is to test whether the population mean symbol is mu. This is the Greek letter mu. We are testing if this mean is equal to a particular number, mu sub o, based on the characteristic of a data gathered from a sample. The symbol for the sample mean is x bar. Let me provide you an example here. The average mathematics proficiency score of Filipino high school students is known to be 80. This is talking about the population, and the standard deviation is 9. A randomly sampled high school students of size 150 took a standardized mathematics proficiency test and their average score is 79. Test whether the hypothesis that the average mathematics proficiency score of Filipino high school students is 80 against the alternative hypothesis that it is not equal to 80. So we are challenging if the first statement, the average mathematics proficiency of Filipino students, that's 80. We are challenging this one by testing our data gathered from that sample, which is coming from the 150 students who participated in the test. What do we need to run a z-test, one sample test concerning means? First, of course, is to identify the population mean, and that is 80. And then our sample mean that is given in the problem, that's 79. What else? We also need the standard deviation, population standard deviation, that is 9. Also, we have the sample size, which is 150. Let us test if the population mean is indeed 80 in this specific context. It's already identified that the appropriate test here is z-test. So let's look for z-test in our list of hypothesis tests. So this is the first hypothesis test. Let's click on this test, and it will give us what we have to complete before it gives a result. So first, we specify the null hypothesis. That is the first step in hypothesis testing. We identify the null hypothesis, and that statement is a statement on the equality of the population mean and what we are testing. Mu is equal to 80. The population mean is equal to 80. That is what we are testing. Now, for the alternative hypothesis, we have three options. Why? The alternative hypothesis is just a negation of the null hypothesis. Our null hypothesis is stating that the population mean is equal to 80. The alternative hypothesis is the negation of that statement, so that we should say mu is not equal to 80. But the statement mu not equal to 80 has two possible results, or two possible scenarios. Either one is less than the other, or the first one is greater than the other. The first two options here are called one-tailed test. It's one-sided. We are testing a specific direction. But if we are just testing in general that the mean is not equal to 80, then it's called a two-tailed test. So how do I identify whether to use a one-tailed test or a two-tailed test? We based it on the problem. So in the problem, it did not say that we are to test an alternative hypothesis that is one-sided or one-tailed. It said that we are testing against the alternative hypothesis, that is, the mean is not equal to 80. So it's not specified. I mean, the direction was not specified. So we leave it this way. We use two-tailed test. And then for the information coming from our sample mean is 79, and the standard deviation is also given in the problem. It is 9, and our sample size is 150. So we are done. We have the results here. Now, there are lots of numbers here, but the most important result, most important because this is what we use to answer the problem, or to solve the problem. It's actually the last number. We call this the probability value. Probability value is, or are, the values that we discussed under distribution in the previous video. So this is the chance of committing a type 1 error. Type 1 error in statistics is an error that we want to be small. Okay, so what is our probability value? It's 0.17. Now, how do we interpret this value with respect to the problem that we have here? If p-value is greater than 0.05, we say that the mean is not significantly different from 80. So it's equal to 80. But if it's less than 0.05, meaning the probability value is less than, it's a very small number, then we can say that the mean is significantly different from 80. Since it's 79, it's less than 80, we can further conclude that the mean is significantly lower than 80. So it's not anymore, the first statement is not anymore applicable. Maybe this is only a conclusion derived from the previous years. So now that the students took the proficiency test, and according to the data from the sample, we cannot say anymore that the average is 80, but something that is lower. It's significantly lower than 80. So there is a lowering trend of the mathematics proficiency of students, we could say that. Now, what else do we have here? So that's how we use z-test one sample. If you look at the next list here, list of hypothesis test, we have the test for a mean. Actually, the purpose of these two tests, z-test and t-test, are just the same, except that we use z-test if the sample size that we have is greater than 30, greater than or equal to 30. We regard a sample to be large if n is greater than or equal to 30. If it's less than, we choose t-test. And the purpose of the test is just the same. The information that we have to complete here are actually just the same. So let's move on to another test. Let's try a difference of means starting with our z-test. So this is what we need to fill out. We have to fill out our null hypothesis that the difference is 0. If the difference of the two population means here are 0, meaning they are equal. Also, we have to identify our alternative hypothesis. We select from the 3. If it's specified that we are testing that one is less than or it's greater than the other one, then we choose between these one-tailed tests. But if it's not, then we choose the more general one. We call this the two-tailed test. This test is appropriate for comparing two means. So we are hypothesizing that the two population means are equal or are not, based on data gathered from two samples. We have here a button where we encode or input the means corresponding to the two samples. So mean for the first sample, standard deviation for the first sample, and the sample size for the first sample. It's just the same for sample 2. Let me give you another problem so we can apply this hypothesis test. This is the problem. A random sample of 20 taken from a normal population with a standard deviation of 5 has a mean of 31. A second random sample of size 24 taken from a normal population with a standard deviation of 4 has a mean of 26. Test the hypothesis that the two populations has equal means. It didn't say here if we are testing whether one is less than or greater than the other. So let's just assume that we are to conduct a two-tailed test. The context in this example is not really clear, but we need, or we got all the numbers that we need to run the test. So let us summarize the values that we find in our problem. For the first statement, we can identify the sample mean, which is 31. We have the sample size, which is 20, and the standard deviation, which is 5. For the second sample, we have the mean equal to 26. Where is that? Here. And then the sample size is 24. The standard deviation is where is that? 4. Yes, there it is. It's 4. So we encode this information here, and then GeoGebra will give us again a p-value from which we interpret and answer the problem here. So let us memorize. The means are 31 and 26. 31 and 26. We have to encode it correspondingly. The standard deviations are 5 and 4. 5 for the first one, 4 for the other one. And then the sample sizes are, what are those? 20 and 24. So we have 20 and 24. There we have it. It automatically gives us the probability value. It's really a small number, If that happens, we can conclude that the two groups are significantly different. The sample with the higher mean is the population with the higher mean. How do we interpret? If p is greater than 0.05, the two populations are not significantly different, meaning they are equal, they are just the same. So despite of having different sample means here, we still conclude that the two populations from which these two samples were drawn are not significantly different, they are equal. However, if the p-value is really small, how do we define small? It should be less than 0.05. The means are significantly different. We can further imply that since they are significantly different, because again the p-value is really low, we can further conclude that population 1 or 2, which is higher, it's population 1. So the first population has a higher mean based on a higher sample mean. The next test here is t-test, difference of means. Again, the purpose of this test is the same with the purpose of z-test, except that we use them in two different conditions. We compare two means using z-test if the standard deviation, population standard deviations are known and the combined sample sizes is greater than or equal to 30. If one of those two conditions are not met, then we have the alternative test. We call it t-test. That means the standard deviations, population standard deviations are not known, or combined sample sizes is really small, that's less than 30. So that's how we can apply some of the tests, hypothesis tests that we have here. What else can we do here? We can estimate. These are the several estimation techniques that we have. We can estimate the mean using z, using t. We can also estimate the difference of means using z and t, and also for the proportion. Let me demonstrate one only. So let us estimate the mean using z-test. What do we mean by estimate mean? It's just the same. We want to estimate the mean of a population, but remember, in inferential statistics, you gathered data from a sample. So what you have is the sample mean. We want to estimate the population mean. So let me just give you an example. I was not able to include them in my PowerPoint, so I hope you can follow through. I will just describe the problem. So suppose you want to estimate the scores of students for the entire region, let's say Cordillera Administrative Region. So we want to estimate the students' mathematics proficiency. Maybe you're only concerned with senior high school graduates. Now, it is impractical, it's very costly if we survey the entire students, all the students in CAR. What you do is to take a sample and then administer your questionnaire, your mathematics proficiency test. Based from the data that you will gather from that sample, let's say you sampled 500. So of course there's a lot of students in CAR, but you only included 500 students in your survey, in your questionnaire. And the mean score that you gathered there is, let's say 80, maybe 80% out of a 100-point mathematics proficiency test. And suppose it is known that the population, I'll repeat, the population standard deviation is, let's say 7, maybe 7, and the confidence level is 0.95, meaning the level of significance or the chance of committing type 1 error is only 5%. Level of significance meaning the chance, the probability that we commit an error. In the remaining percent, that's 0.95, or 1 minus 0.05, that's what we call confidence level. So where is the estimate of the population score, or the mean score for your population, which includes all the students in CAR? It's actually the numbers that you see in the bottom of our software. So we can start with our lower limit. We have 79.3864. We have also our upper limit, 80.6136. Meaning, our estimate must lie between these two numbers. So our estimate for our population lies between these two numbers. It's really a very tight interval. So that's what we want. That's good. Because if the interval is really wide, then the estimation might give us a very unreliable result, because we have to choose from a very wide interval of numbers. So that is an example of how we estimate the mean using z-test. We can also use t-test if you want, and the other estimation concepts here. Estimating the difference of two means, that's if you have two populations and you want to estimate the difference of the means of those two populations. So I guess I'll end here. That's how we use our GeoGebra to conduct the different hypothesis tests. Thank you for listening.